Let's calculate our margin of error, and we are only playing with an estimated 95%. So there's some really tricky formulas when you're really digging into the statistics behind this, but we're going to use an estimated. So the margin of error is an approximation of how far off a sample's reported percentage might be. So when you do a survey and you get you come back and you have some information, you know that it's not going to be exact because you're only sampling a small amount, not everybody. So that's going to change some things. So the margin of error allows you to make a little bit of mistakes here. Now, in order to approximate the 95%, the margin of error is going to be plus or minus 1 over the square root of n, where n is the sample size. Because the number of people that you're surveying, that matters. That makes a difference with your sample size or with your margin of error. So our estimation is 1 over the square root of n, and it's plus or minus because when you have your value, we are going to subtract the margin of error on the left, we're going to add the margin of error on the right, and that then gives you the interval, right? We need a low end and a high end. And your sample value that you found from your survey is going to be right in the middle. So let's look at this. Let's estimate the margin of error from a sample size of 1095. So that tells us that n is 1095. So the margin of error is going to be plus or minus the square, plus or minus 1 over the square root of 1095. Well, what is the square root of 1095? I don't know, but you can type it into your calculator. So depending on your calculator, you can type in 1 divided by the square root of 1095, close your parentheses, and it's going to spit out 0.03. So as a percent, that is 3%. So our margin of error is plus or minus 3%. What if our sample size is 2,000? Well, okay, so now n is 2,000. So we would have plus or minus 1 over the square root of 2,000. So 1 divided by square root 2,000, close parentheses, and we get 0.022. As a percent, that is 2.2%. So our margin of error is plus or minus. Again, remember the margin of error needs that plus or minus because we're going both directions. We're going to subtract it from our sample. We're going to add it to our sample. Let's make our sample size 3,500. So now n is 3,500. So plus or minus 1 over the square root of 3,500. So 1 divided by square root 3,500. And that gives us 0.017. As a percent, plus or minus 1.7%. Now, what happens to the margin of error as the sample size increases? So we started with a sample size of 1095. Then we went to 2,000, then we went to 3,500. And what happened to the margin of error? Well, first we had plus or minus 3%, then we had plus or minus 2.2%, then we had plus or minus 1.7%. So you can see, as the sample size increases, the margin of error decreases. And this goes back to the law of large numbers. The more people you talk to, the more closely to the actual truth you're getting to. Okay? So that's kind of what it goes to. And if we would go even higher, if we would talk to 5,000 people, then our margin of error would continue to go down. If we would talk to only 500, the margin of error would get higher. Because if you don't talk to very many people, you're more likely to be wrong or not have accurate data, and therefore you just will have a larger margin of error. Moral of the story, if you're doing any kind of a survey, you want a large sample size. The larger, the better, because then you have more accurate data and you'll have a smaller margin of error.